Hello and welcome to this EdgeConnect tutorial on the OPC UA Device Service. In this tutorial I'll be talking you through getting up and running with the OPC UA Simulator as well as some commands for the OPC UA Device Service. This page here is the EdgeConnect user documentation page. From this page you can see detailed instructions about how to use all of our various simulators for our services as well as instructions on how to get up and running with the device service components. However, for now, I'll just direct you towards the Getting Started page. In this page, there is a tutorial about EdgeConnect setup steps. This includes installing the MQTT client required for these tutorials, as well as installing EdgeConnect itself and ensuring your license file is set up correctly. This tutorial is a prerequisite to the OPC UA Device Service tutorial, so please ensure you have completed all the steps here before continuing. It is worth pointing out at this stage that EdgeConnect is the name of IOTech's new OT connectivity product, but it is based on our existing product XRT. So in this tutorial you may see some references to XRT rather than referring to it as EdgeConnect. So to get started we will first clone the XRT-Example repository. In this repository you will find examples of all the different device services supported by EdgeConnect. These device service examples contain detailed walkthroughs of how to get up and running with the various device services, as well as some basic commands. And this tutorial will be a walkthrough of these commands. So to get started, let's clone this repository. Once we have cloned the repository, we need to cd into it, and we then need to check out the version 2.2 branch, as that is the version we'll be working with. So this is the README for the OPC UA Device Service example. You can see the first step that we are running in this tutorial is to start the device simulator. So let's open this repository from inside of VS Code. So if we navigate to Device Services and OPC UA, you can see that we have three folders underneath OPC UA, the top one of which is this commands folder. Essentially this is pre-written shell scripts for implementing various common steps for the device services, as well as, for example, starting the device simulator. So let's see what this shell script is doing under the hood. So you can see this shell script here. You can see it is essentially pulling two Docker images, one of which is for the OPC UA Device Simulator, and the other of which is for LDS, which stands for Local Discovery Server. This will allow discovery, which was something we will look into later on in this tutorial. So after pulling these images, you can see that it then runs them, with the OPC UA one running this example script here, which we will look at now. We can find this Lua script within the simulators folder of this XRT-Examples repository. So within OPC UA, we can find simulation.lua. I will not go into great detail of this Lua script. There is detailed documentation within this video description. So let's now run that command. Let's first cd into the correct folder, so Device Services OPC UA. From here, within the commands folder, we have Start Device Simulator. So that will start the Docker containers in the background in detached mode. So you can see it will pull whatever Docker images are required. Once those have been finished, it will actually run them. Let's check that now. So you can see we have two containers running. So let's navigate back towards the tutorial page. So next step is to set environment variables. So you can see we have pre-written another shell script. However, this isn't within the commands folder. This is actually at a higher level because it's common across various device services. So set envars. Let's just have a brief look at that shell script. So you can see within here, so you can see these environment variables are dependent on the context in which you're running them from. So please ensure that you are running them from the OPC UA folder within Device Services. So let's have a look how these are actually used within our setup. So for example, you can see we have profile dirs, state dirs, config dirs, and MQTT users username and passwords. If we navigate back towards the OPC UA folder, within the deployment section is where we will actually be running EdgeConnect from. So inside of here we have a config which contains various setup for the OPC UA Device Service, for example. And here we can see some of those environment variables being used. And we also have other aspects such as the MQTT bridge set up for EdgeConnect in general. And also you can see a reference to the profile directory. So this profile directory comes pre-supplied with different profiles for this device service. However, in your use case, you may have to set up your own profile file. You could base it off this, or you can generate it through device scanning, which I will talk you through later on in this tutorial. Or alternatively, you can create your own through the device configuration tool, which I'll show you briefly how to do now. So this is the device configuration tool, the link for which can be found in the video description. Essentially, this allows you to create device profiles simply and easily, so it'd be very helpful in your own setup where you will not have a pre-written profile file like we do in this example. So I won't go into full detail here as we have another tutorial on this, which I will link in the video description as well, but I'll just give you a brief introduction. So we can add in a device type. We can see that we can select any of the protocols supported by EdgeConnect. Of course, we are using OPC UA in this example. Let's give it a device type name, OPC UA Sim. Save to add that as a device type, and then we can add resources as well. So let's actually replicate a resource that we've confined within the pre-written profile. So here we have a resource with a name of NS3 representing namespace 3 and random value of type float34. Identifier type is string. So let's try to remember that and add that in as a device resource. So we can pre-selecting this as our device to add this resource to. So this is the sim that the device type that we just created. So here we actually are adding in the resources. So it was namespace equals 3, s equals random value, data type is float32, read and write read write should be read write. I'll leave all of these as this is just an example. So namespace was 3, identifier type was a string. So yes, we can create that now. Oops, identifier, apologies. Identifier was random. So I can save and create that resource now. So of course you would probably be adding more resources than simply one resource, but this is just for demonstration purposes, so I can click finish. And then finally we actually have to add a device profile which will use these resources that we've created. So let's call this OPC UA Sim Profile. Next. And now we can select resources that we want to associate with this profile. So we'll add this one that we've just created previously and save profile. So if you are a frequent user of this device configuration tool, you can have various profiles created, each referencing different selections of the resources. And this, once you create the profile, you can then export it in various formats. In this example, we are using it in JSON form. So I'll just have a brief look at this. So you can see here, this essentially replicates the resource that is pre-provided, or one of them. And you can see this, we have the name here that we set, we have the value type, we have the node ID, we have the namespace, and we have the identifier type. So that should hopefully give you a brief introduction to the device configuration tool. As I say, we have another tutorial on this, and that will be within the video description. So having had a look at profiles and a brief look at the Lua script, we can now carry on with this tutorial. So you see previously we ran that set environment shell script, and now we have to set some environment variables specific to OPC UA. So we are able to simply copy this and run this command. Copy this for the LDS sim as well. And now you can see we are actually pointed towards another getting started page. However, in this tutorial, a prerequisite was watching the EdgeConnect getting started. So within that, we actually cover these steps. So if you have followed that EdgeConnect getting started video, you do not need to look at this page here. So now with our environment variables set up and our simulators running, we can now actually start EdgeConnect. We can run EdgeConnect running XRT deployment and then pointing it at that config directory. So I'll run a Mosquito client subscribing to any topic under the XRT namespace. So as you can see, we're already getting messages coming through on the telemetry topic. And the reason that we're getting messages coming through already is this example comes pre-configured with a schedule that's been set up. So you see this is a schedule which essentially is a regular GET request to the device service. So we have the device set up here for OPC UA Sim. We have an interval of 3 million microseconds or 3 seconds, schedule name and a resource that will be polled at the given interval. So that is why we're seeing these telemetry readings coming through here. It's a nice way that we can see that the device service and EdgeConnect and the simulator are all up and running correctly. So we can continue with the tutorial. So the next section of the tutorial is actually common across all device services. So it's navigating us towards the basic operations walkthrough. So let's get going with that. So these we have already set up, these prerequisites, and we can now move on to the actual tutorial itself. So essentially the format of the tutorial is to show you some commands associated with all the device services and how to actually interact with these devices. So the first command in the tutorial is the remove device command. So let's navigate back over here and look at what constitutes a command. So within the remove device shell script, all the commands are essentially MQTT messages to the request topic underneath OPC UA, as of course that is the device service that we're interacting with. So specifically the remove device command, it has an operation associated with it, and it's within the namespace device, and the operation is delete, and of course you need to give it a device here to delete. So this device essentially refers to one of the devices that EdgeConnect has been pre-provisioned with in this example. So let's navigate to the state directory. Essentially, this is all the files associated with the running deployment of EdgeConnect. So we saw before the config directory, which had all the pre-configured aspects of EdgeConnect, and here we have the state directory. So within the state directory, this is essentially continuously kept up to date by EdgeConnect and stores all the running devices underneath devices.json. So here we of course have the two devices, one of which being the OPC UA Simulator and the other of which being a device to represent the local discovery server. As well as having a devices file, we also have a schedules file which we looked at briefly before, which contains a list within JSON format of all presently running schedules, which is just one in this case. And let's run that commands remove device shell. So you can see already that this state directory has been updated. So within this devices.json, you see that we no longer have that standard OPC UA simulator. And within the schedules, you can see that that schedule has also been deleted because the device that the schedule was running for has been deleted as well. So that is why the schedule has been deleted. So we're now going on to the next stage of the tutorial, which is to re-add that device. So let's have a look at that command. So add device.shell. So here it is. So again, similarly, going to the request topic, which all of these will be, a different operation this time, of course, device add. However, when adding a device, you need, of course, to include more information than when deleting it. So you need to have a profile for the device and the protocol, which of course in this case is OPC UA. And we're using the environment variable OPC UA sim address, which is the address of the running Docker container. So let's run that command. And again, just briefly, within that state directory, we now have the OPC UA sim that's been re-added. Of course, the schedule has not been re-added because that was deleted when the device was deleted. So there's no storing of schedules for deleted devices. So we'll need to add that on later if we want to. So let's look at some basic requests, such as get request and get multi-request, starting with get request. So here we have the get request command. Similarly, it's just a mosquito, it's just an MQTT message. And here we give it a device name and a resource to get. So let's run that command. And let's go over to the Mosquito client here. So here you have the get request itself with a device of OPC UA Sims, that's the device name, and the operation of device get, a unique request ID associated with it, which will then be quoted back in the reply that we can see here, and of course a resource name with which to get the to perform the get request on. So here you have the response from Edge Connect with a value of 1.7 times 10 to the power of 3. So let's move on to the next stage of the walkthrough, which is multi-get request. Let's look at that command here. So get multi-request. So very similar to the get request. However, rather than just passing a single resource name, you can pass through a list of resources. So let's run that now. Multi-request and navigate back over to our Mosquito client. So here is the request, which is the message that we sent, and then this reply here, which has the various values of the resources that we requested. So let's carry on. Now we can, of course, you have gets and you also need to write data. So let's have a look at the put request shell script. So here it's very similar to the other commands that we've looked at. The operation is put instead of get, and in this instance you need to pass through not only the resource name but the value that you would like to write to that resource. So let's run commands put request, and here in this response we have the reply and we have a status of 0. That status simply indicates that this has been a successful put request. So again, very similarly, we have put multi-requests, whereby you can write to multiple resources at once. So here you will have a list of resource names to the value that you would like to write. So let's run that now. And here again you have the request message going through, and then on the reply topic we have status 0 to indicate success. So as you can see, that is how you can interact with the device service simply through request reply topics within MQTT namespaces. So now that we have looked at those basic get and put commands, we will move on to the schedule management section of the walkthrough. You'll remember when we first started running Edge Connect, we saw messages coming through on the telemetry topic, which were due to a schedule being run against a certain resource of the OPC UA device. So here we have the command to add schedule. So this is how you can also set up schedules for your devices. So the add schedule command, here the namespace is no longer under device but under schedule, and you have to give this schedule a device as that it will perform the get request on, and a name, as well as a resource name and an interval that the schedule should be run on. So let's run the command. Before I actually run the command, let's look within this state directory, and we should find that under schedules there is actually no running schedules for this device, or in fact any device associated with this EdgeConnect instance, which is expected. However, after running the add schedule command, we see that this schedule has now been added. So this is the device, the OPC UA Sim, and that's the schedule name. So if I go back over to the Mosquito client now, not only will you see messages coming through on the telemetry topic at an interval of 1 second, but we can also scroll up and see that this is our add schedule command running. So there you not only can tell that it was successful through messages coming through on the telemetry topic, but of course you will always get that reply with status 0, so you can be sure if, for example, you're running this at a much greater interval, you can still be sure that the schedule has been added correctly through that response on the reply topic. So it's very similarly, you can also delete schedules as well, which are removed in a very similar fashion to how you delete devices, where you give it an operation of schedule delete and a schedule name. So let's run that now. And this will mean that the schedule will be deleted from that schedules.json. So we have looked how to add devices, how to remove devices, as well as how to interact with devices. Next we looked at schedules, and the final stage of this generic walkthrough for the device services is around operational state. So essentially what operational states allow you to do is to mark a device as offline, which means get and put requests to that device will be rejected, and you can do this without deleting the device, meaning you can re-enable the device later at a later date, and you will not have to reconfigure it. It will simply be marked as operational. So first, let's set the operational state to false, and what this command does, operation state false. So it's a update command, so you're updating something associated with the device info. In this case it is operational to false. So commands false. So if we just have a brief look at the Mosquito client, you can see that here we have our request that we send through here to set the device info operational to false, and we have the reply here which marks that as successful with the status of 0, and we also have this message here which is updating us on the OPC UA device status. So this is simply telling us that operational is now false. So if, for example, I run that GET request that we ran at the start, here you will see that our reply doesn't have a status of 0, has a status of 6, and you'll see a corresponding error message which is device OPC UA Sim non-operational. However, if we look within this state directory, you can see that the device itself has not been deleted and is still present. So when I run the command operation state true, what now happens is I will be able to make that GET request and without issue. So let's run GET request. So this time we do not see that error message come through, we instead see a successful GET request. So that is the end of the generic section of the OPC UA device example. So we can navigate back towards the specific OPC UA example to continue with some commands that are specific just to OPC UA and not common across device services. So the OPC UA Device Service supports subscriptions. There is further documentation available for what this means here. We won't go through it now, but you can see the link there. But let's get on to the actual commands of how you would add a subscription. So let's have a look at the add subscription command. So adding subscriptions is done in a very similar way to adding schedules, and they are managed all under the namespace of schedule. However, in this case, the interval is actually ignored, and it's instead done through auto events. So here you give a device name and you give a resource. So let's run that now. So essentially subscriptions are handled as schedules under the hood. So you can see that this will be added into the schedules .json. And let's navigate over towards the Mosquito client. So what you will see this coming through, and then you will see a source name is given to these subscriptions, so you can tell exactly where it's coming from. And the reason this is updating as it is because the OPC UA Simulators has a counter resource, which is what the subscription was added to, which is constantly changing. So you can see here that changing value coming through is the reason that we're seeing this subscription being actioned frequently. So very similar to, we'll have the remove subscription command, which you will be able to assume what it is now, but let's just have another look. It's done in the exact same way as deleting a schedule. So schedule, delete, however the name of course will be different. And yeah, if we look at the client, you can see this reply status 0, and we no longer see those messages on that telemetry topic. So the final section of this tutorial is around discovery and profile generation. Again, this is navigating you into sort of a generic walkthrough, as this is also supported by some other device services within Edge Connect. And let's move on to the discovery guide now. So let's initially delete the devices and the profiles associated with them, as this will allow us to start with a clean slate. So let's do that now. So let's remove device. So there we have removed the OPC UA device, and let's also remove the device profile. So here we have our profiles file. So this contains all profiles associated with Edge Connect. We've now deleted the OPC UA profile, so we just have the LDS profile, and we have no devices here. Just the LDS device as well. So essentially what this discovery and scanning will allow you to do is, through running discovery, Edge Connect can discover devices that can be connected, and then through running scanning, which we'll do afterwards, a profile file can be generated for a discovered device. So let's first run the trigger discovery command. So if we look at what's happening here, so this is our request that came through that we sent to trigger discovery, and we see immediately we've actually got something come through in the discovery channel, but we also have of course that reply to indicate that this has been successful. So in this discovery topic, you can see for example, you see a list of devices that were discovered, and you can see information associated with these devices. For example, the different addresses. So we have this address here, and we have this address on a different port up here. So once you have run this discovery, you can then scan the desired discovered device. So let's have a look at that command now. So scan discovered device. So here we got a device name. So with that information that you can see coming through on the discovery topic, what you can actually do is add that as a device in the same fashion as we added the device in the previous example. So let's run that command now. Commands add discovered device. So this would be filled in using information from that discovery message that you see come through after you've triggered discovery. So add discovered device. We can now navigate to that devices.json and we can look and see that we've got another device added, which is the same, of course, because we're pointed towards the same simulator. We can see the name of OPC UA Sim, and we can see the address there has been set up correctly. But what you will notice is that in our profiles file, we still just have that LDS profile. So we still haven't added a profile for that OPC UA Sim. And what we will do is we will actually do that through scanning the discovered device. So what this does is ask EdgeConnect to actually generate a profile based off information it can receive from the OPC UA device. So let's run that command. Scan discovered device. So here we have the namespace of device, we have scan, and we need to give it a device name. So I'll run that now. You can see already in this profiles directory, we've got a unique name for this profile that's been generated. And you can see this is actually the same profile file that was provided. However, this has been, of course, auto-generated for you by EdgeConnect through scanning the device. And worth pointing out is that this profile will not just be scanned, it will be automatically added in and associated with the device that it was scanned from. So you can see their profile name, which has this unique key that was generated by EdgeConnect for this scanned profile. So having added that discovered device and scanned that discovered device, let's just check that it's all working as anticipated. We can check that through running a GET request. So we're now running this GET request, which is the same as before, but of course this resource name is now, pointing towards a generated resource name when we scan that discovered device. So if I run that and navigate towards the Mosquito client, you can see that this has been successful running against the scan profile rather than the profile that was pre-configured at the start. So this is simply rerunning back through that exact steps that we just did. So with that, we now conclude this OPC UA tutorial on the device service and how to run the simulator as well. So I hope this has been helpful. As I mentioned, there are lots of other more detailed links in the video description with documentation regarding the simulator itself as well as the device service. So thank you for watching and take care.